So it says the total spent on research and development is given by this equation here. And then they want to know what the total spent in 2009 is. That is taking this value of t, putting it back into the original equation s of 9. So that's 3.1 natural log of 9 plus 22. That's purely a calculator problem. It's just around the nearest whole number for that. So whenever something asks for increasing or decreasing, you have to associate that with the derivative. So if s of t is given as 3.1 natural log of t plus 22, you have to be able to find the derivative here, s prime of t. So do you recall the derivative of natural log of t?
Isn't it 1 over t?
Yes, this is 3.1 times 1 over t plus 0. So this is 3.1 over t. And then when it says how fast was it increasing, it's referring to this year, which they probably could have made it a little bit more clear. But they're asking you to find s prime of 9, which is 3.1 over 9, which is how you came up with that value that you entered in there.
Okay.
All right, so let me look for the next question. Next one is just a derivative. So let me pull that one up. Snip that in. Okay. So the derivative of the function is this is the function up here. You got the answer right, but let's just work through this again. This one would be really good to look at this as e to the u, where u is equal to 2x squared minus 9x plus 6 over x. That was one way you could write it. What is the derivative of e? Do you recall?
No.
It's itself. It's itself.
Oh, okay.
So it's the only function. It's called the transcendental function. Big deal. It just means that it's itself, and then it's times the derivative u prime. So whatever is
Okay.
up here, you have to take through it, and that's why all this stuff. Well, it's in front here, and that's why all this stuff is here. So what is u prime? Well, before we do that, let's just rewrite this slightly. Plus 6x to the minus 1. So u prime, come over here to the right. That's power of 4x. Great. Minus 9. Okay. This minus 1 comes in front, so minus 6x to the minus 2 power. And now it's just a matter of substituting in. H prime of x equals e to the u. That's all of that stuff up there. Times u prime, 4x minus 9 minus 6x to the minus 2. WebAssign will accept a lot of uh, variations in the way it's entered.
Okay.
Do you want me to give you one like this, or just keep going through the questions?
Yeah, I'll do one like that.
Okay. So if I give you a function, I'm going to tell you that f of x equals e to the 4x squared minus 3x plus 2 over x squared. You're going to, and this is how I'm going to start you out here, you're going to write this as e to the u, where u is 4x squared minus 3x plus 2 over x squared. Okay, so go ahead and start from here. Take about 60 seconds and see if you can work that out on your own, please.
Okay. Okay, I think I got it.
All right, so I'll write the solution here. So f prime of x is e to the u prime. U prime is 8x minus 3. Now this right here can be written as 2x to the minus 2. So when you bring that negative 2 down, it's minus 4x to the minus 3. So the final answer is e to the 4x squared minus 3x plus 2 over x squared times, and that's at the level of e, 8x minus 3 minus 4x to the minus 3 power.
Okay, perfect. That's what I had.
Excellent here. Okay. So I'm going to go to the next one here, which is 6. And oh, looks like your instructor gives you some extra credit for early submission. That's not all of them do that, so that's nice to
Yeah,
see.
nice.
All right, so s of x in this case is u cubed, where u is equal to 3x minus 9 over 2x plus 8. Do you remember the quotient rule from last week or for your exam?
Yeah, I remember it.
Okay, so the way it goes, it's you take the bottom, and and then you multiply it by the derivative of the top. What's the derivative of the top there?
Of the 3x minus 9,
Yes,
it's just 3.
just 3 minus the top times the derivative of the bottom. What's the derivative of the bottom?
Just 2.
Just 2. Okay, over the bottom squared. How the heck did you get? Oh, okay, never mind. Sorry, I'm getting ahead of myself. Okay, you don't have to simplify this, but we could. I guess. No, it doesn't even tell you to do that. Like you could literally leave this as your unsimplified derivative. So over here, s prime of x, this is just power rule. It's 3u squared times u prime. Now you might be saying, well, how does that work? Well, u is this thing over here, this 3x minus 9, 2x plus 8. I'm just fitting the pieces in, this, there. And then u prime, all of this has to come next to it and goes there.
Okay.
Now it simplifies to all this nice up here, which I mean, I'm assuming you got from an online calculator, which is totally cool because I mean, you can do that, but WebAssign should accept this big, massive, ugly thing.
Okay.
Would you like to do one like this?
See, yeah, I would, because I just got thrown off when it was like cubed, so I
Yeah.
should probably practice something like that.
So that number won't matter. Here, let's do let's s of x equals 4x minus 1 over 3x plus 2 to the power of 4. So this is really u to the 4th, where u equals 4x minus 1 over 3x plus 2. So give that a shot, please.
Okay. Okay, I think I got it.
All right, so here I'm gonna write out the solution. So s prime of x is 4u cubed u prime, and here's what that looks like. So it's 4, and then u is this thing over here. So that's 4x minus 1 over 3x plus 2 to the power 3. Now u prime is the following. It's the bottom, 3x plus 2 times the derivative of the top, which is 4, minus the top, 4x minus 1 times the derivative of the bottom, which is 3, over the bottom squared.
Okay.
And yeah, if I mean, WebAssign will take this, you don't have to do any simplifying. In fact, I wouldn't. Okay, we've got a problem here. Number 9 is the next one I'm seeing. Let me snip it into our workspace, and looks like just this is like a application of derivatives. All right, so they give you a function, yay. They give you, oh, so they give you a profit function, and they give you a quantity function. And then they want you to find dp dn. Okay, so so they say use the chain rule, and what they mean is that up here, whenever you take a derivative with respect to q, you have to include a q prime. So like, let me try to explain that here by actually going through the it. So p prime equals the derivative of minus 100,000 is 0, but the derivative of 5,000 q is 5,000. But since q is a function of another letter, you have to write q prime.
Okay.
Okay, so now the same thing is going to apply um, to the next term here. It's power rules. That 2 is going to come down. It's going to be minus 0.5 q. Okay, and then you multiply it by, well, the derivative with respect to q is q prime.
Okay.
Okay, so some students don't like that, so let me show you just another way to look at it. You take the derivative of this as you always do. Okay, so another way to do this is, okay, well, it's 5,000 minus 0.5 q, and then you take the whole thing and multiply it by q prime, which is the same thing as what I've got up above, but it's kind of up to you how you want to look at it.
Okay.
And just like we did with the u's, you have to find q prime. So we go to this one down here. Let's bring it down here. Q prime is equal to 30 plus 0.02 n. Now you might say, well, Matthew, how come there's not an n prime here? That would be totally reasonable to say. It's because n is no longer a function of something else.
Okay.
Like you're at the end, so you don't have to worry about that.
Okay.
So now we have to do something with this. So there's a lot of pieces here. We need to get q prime. So q prime of 10 equals 30 plus 0.02 times 10. So that equals 30.2. Okay, and that's the number that's going to go in here for q prime. Now we need q. Well, to get q, we have to use this value of 10 again, but we have to use it in this thing up here. It's 30 times 10 plus 0.01 times 10 squared. So this is 300, and that's 100 times 0.01. So this equals 301. So now we have the two values we need, because we need q. Q is going to go there, and then q prime is going to go there. So this equals 5,000 minus 0.5 times 301, and then q prime is 30.2, and that's how you got that there.
Okay.
Now the values in these boxes here, this is the interpret. Let me actually, oh, they actually write it there. Interpret. They used to have you write a sentence before the pandemic when we couldn't go to school. Now that you've got everything online, they give it to you here. The level of 10 comes from this box right there, and whatever your answer is here, you can see that it also goes in that box there.
Okay.
I know it's a lot of arrows. If you
You're good.
rewatch this, it'll make sense. If you do it again, it'll make sense as well.
Okay.
Um, one more for this set, so you might want to queue up a few more questions for us to work on. But we'll be done pretty soon with this question. So this one, these seem sort of all over the place. Is this all from one assignment?
It's from 2 that
Okay.
we'll do today.
All right. If $20,000 is invested in a savings account offering 3.5% per year compounded continuously, so that's very important here. How fast? Now, whenever it says how fast, that's a derivative.
Okay.
Remember in an earlier problem it said increasing,
Yeah.
decreasing. That means derivatives. You have to be looking for that. Before you can even do this, though, you have to know how to write the function. So the amount of money you have as a function of time equals PERT, P-E to the RT. You probably saw that either in high school or in a previous math class in college. So P is the starting amount. Okay, and we have that. That's the 20,000. E is just your exponential function. R is your rate as a decimal. Percentages are great, but they're not used in the math world. We always convert those to decimals. And then T is your variable, so you're gonna keep that. So if you followed what PERT is, then I'm just going to substitute the values. $20,000 for P. E is a function. 0.035, and then T is the variable. So you're used to just putting a number in for T, but that's not what this is asking for. It's asking you to find the derivative first. So you have to find the derivative of this function. So you have to first be able to write it, second get the derivative. 20,000 is a constant, it just comes along. What is the derivative of E? We talked about that earlier, do you recall?
Yeah, it's just e to the whatever it was.
Exactly. And then we have to take a derivative now of this inside part. This is U, this is the nested part of the function. What is the derivative of a number times a variable?
It's just a number.
Just the number, good. Okay, so this is it. Now you can combine these if you want, but you have to put a value of T in to get a number anyway. So they're asking for it in 4 years. That's given in the problem. That's the red number. 20,000 e to the 0.035 times 4 times 0.035. And that's how you ended up getting 805.19 for this problem.
Okay. Okay. That makes sense. Okay, I just found some problems I'll send real quick.
Okay.
Unless if you just wanted to log in, I was just going to start working on my 12.1 homework.
It's totally up to you. If I log in, what I do is I just snip them and grab them into the workspace.
Okay, I'll just send them real quick.
Okay. Are you studying on campus right now, or are you back home, wherever home is for you?
I'm on campus, but I'm at home today.
Okay.
Okay.
Are you trying to get into the Carey School of Business, or are you already in, or what's the goal here?
I'm already in.
Awesome. Great.
All right, I'm just waiting for another screenshot to load. Okay. I just sent over 4 problems.
Okay.
I can send more if needed.
Well, we'll go through these, and then you can repeat if needed. Depending on the problems, it could take 4 minutes, or it could take the rest of the time. Just depends. Okay, 4, 9, and then a few others here. Okay. All right. Okay, so I'm gonna just start with question 9. If that's okay?
Yeah.
Actually, I should start with question 4. That's be more appropriate.
Did I send, I think the first 2 I sent, like the very first one is number 1, and then the next one is 2, and then it goes 4 and 9.
Okay, so
Sorry.
the 2 of them did not come with the question number. So let me just snip this in, and you can tell me if this is question 1 or not.
Okay, sorry about that.
That's okay. Is this question 1?
Yes.
Okay. If it isn't, or so singular points are not. Okay, singular points. Okay. So they're asking you to look at the graph and decide what you've got going on here. So one of the things you're looking for are endpoints, and you've got 2 endpoints. You've got one here, at -6, 0, and you've got one here at 6, 2. Okay. So then the other points you're looking at are here and here. These are where the horizontal tangents occur. Maybe you saw that in class. So the first one is -2, 4. That's this one on the left. And this next one is 2, -2. Do you have the ability to just check these before I go on? Or like,
Yeah,
do you
do
have
I
enough?
put in like the
I'll get to this part, but my intuition tells me these endpoints might not be included in your class, but I'm not sure.
okay.
It just changes a few minor things, but
Okay, all of those were in the correct order and they were all correct.
okay, great. So like, let's look at this point over here on the left. This point relative to something nearby it is smaller than another point. Now, the next question you ask, well, is it the most small of everything? And the answer is no, because there's a smaller value here, but relative to everything around it, it's a relative min.
Okay.
Okay. The next point here, compared to everything around it, it's a max. It's a relative max. Okay, but because it's bigger than everything else, it moves to an absolute max, if that's an option there for number.
Okay, yeah, it is.
Okay. Same thing here. Like this is a min. It's a relative min. You always start with something as either relative, min, or max, and or nothing. And then you're like, well, maybe it's an absolute min. Well, it is if it's smaller than everything else, which it happens to be.
Okay.
When you get to this point on the right, you say, oh, well, it's bigger than everything around it, so it's got to be a relative max. Is it the absolute max? Well, no, this is bigger. And that's
Okay.
how you make those decisions for that.
Okay.
So if that was clear, maybe it would be good for you to try the next one on your own, and then I could fill in the correct answers here after you've taken an attempt at it.
Okay. Okay, I got all of it except for
So the way I look at this is this first point, -3, 2. I can tell that it's higher than everything else, so it's an absolute max. This point down here, -1, -1, it's the smallest of everything, so it's an absolute min. But this point on the right, 3, 1, it's higher than this stuff, but it's not the highest of everything, so that's why it's a relative max.
okay.
It's kind of like if you're hiking. It's like, well, I'm higher than everywhere else if you've ever been on a hike, but I've got to get to this higher point that's up further up on the mountain. And sometimes you go down to go up when you're hiking.
Okay. Okay. That makes sense.
So the first couple are nice because they give you the graph. The next two that you've sent do not have the graph, which means that you could graph them. And does your instructor allow you to use Desmos or technology to graph, like besides a graphing calculator?
Not during exams, so we'd have to
Hmm,
use like our graphing calculator.
well, that's lame. It it's like writing someone a letter when you can text them.
Yeah.
Um, Okay, so here there is sort of a recipe to do this. The first thing you do is you check the endpoint, or you evaluate the endpoint. So you find f of 0, which is 2 times 0 squared minus 8 times 0 plus 2, and you get a number. That's 0 minus 0, so you get 2. Then you check the other endpoint, 2 times 3 squared, 8 times 3 plus 2. So that's 9 times 2, that's 18, minus 24, so it's minus 6 plus 2 is minus 4. Now you leave a little space and you find the derivative. So the derivative of this, f prime of x, can you give that to me? Can you tell me what that is, please?
Yeah, 4x minus 8.
Yeah, 4x minus 8. And what you do here is you set it equal to 0. What value what value for x makes this equal to 0 when x equals
2.
2? So now you go back up here and you find f of 2. So you have to go back to the original function, 2 times 2 squared minus 8 times 2 plus 2. So that's 8 minus 16, so that's minus 8 plus 2, so that's also minus 4. Is that right? I wonder if I made a mistake on one of these other ones.
It was.
That doesn't seem right. This should be minus 6.
Yeah, minus 6.
Okay. Now, this is a very straightforward question. What is the smallest number in this list?
Like,
So this one down here is the smallest number. That is the absolute min.
okay,
What is the largest number in the list?
the 2.
So it's an absolute max. This one's a little harder. The graph would tell you about this. So it's a little bit hard for me to explain how to do this without the graph. Um, do you? I don't want to do this. Do you have any idea what this looks like graphically?
I can graph it real quick.
Okay. So what you'll see at 3 is that that's the sort of the bottoming out of it.
Okay.
So it's a relative. No, it's not. There's something. So I do I do need the graph.
3, -4, it's like,
Let me.
uh,
I'm gonna graph this and then snip it in so I can show you what I
okay.
thought I was gonna see, but no, I don't want that. Yes, I just want the graphing calculator. All right, y equals 2x squared minus 8x plus 2 from, let's see if it'll do that, 0, comma 3. We'll do that. Nope. All right, gotta do it the old way. All right. I'm just grabbing some points here so that it's kind of clear. Let me snip that in. All right, so the graph is coming here shortly. So from 0 to 3, the graph of the function looks like this.
Okay.
So this is the absolute min down here. We already discussed that, and this is the absolute max.
Yeah,
Now, at this point, compared to everything around it, what is going on? Is it higher than this point, or is it lower than the one to the
it's
left?
higher.
So it's a relative max. It's just a
Okay.
little bit higher, and the graph really makes this clear
Yeah.
for you. So that's a nice thing about having some technology, which you're not allowed to have on the exam, but we can at least talk through it a little bit here. All right. Great. So we got number 9 is the next one here to do. Are the ones in between ones that you already know how to do, or you're just not, you just didn't send them? What's the?
I just didn't send them because they're all
Okay.
like the same.
Yeah, they are very repetitive. You made good choices. These are kind of, you know, the previous one illustrated something. This one kind of illustrates something. All right. This one says to round to two decimal places. So whenever I see that, I know you're going to use your graphing calculator um, or some technology, but it's the same thing as before. You're going to evaluate at the endpoint. So 5 times minus 4 squared minus 50 times minus 4 minus 1 to the 2/3 power. And then you're going to do f of 4 equals 5 times 4 squared minus 50 times 4 minus 1 to the 2/3 power. I'm going to graph this one again because it's useful for what we're trying to accomplish, which is understanding what this thing looks like.
Okay.
But you probably want to give it a try graphing it on your side just to see if you're comfortable comfortable with that, because if you haven't graphed in a while, it can just be daunting. All right, actually this is an open interval. Why is it doing that? Okay. um, so I shouldn't have checked the endpoints because they're not included in the domain unless I misunderstood something about this question. Yeah, now that I see that. Okay, so I'm gonna change my window here. The window is really narrow. Um, to see this, you got to look from -4 to 4, and then I think you'll see. Let me grab that point, and then that point. Sorry, I got some things I have to move around to get this to snip in, and then it'll be very clear. Um, what I find with most students is getting the correct window is hard. So this is not correct because the endpoints are not included. So you don't actually do check the endpoints when it's an open interval like that with parentheses.
Okay.
So my mistake for jumping in there with that. So what you're going to see here, because I got this nice window, which this tells you the window on the x. This is your x min and x max in your graphing calculator.
Okay.
You definitely want to play around with that, and then you got to get this to where you can actually see it. So you can see this one comes down, comes up, and then comes back out, down. So these are the 3 points that they're interested in. Um, this one down here, it's a min, but is it an absolute min?
Is it for the window?
So what I did is I cut this thing off so like it ends there and there. So what you're seeing is everything. There's nothing hidden. And I'm just asking you, is this the smallest point? Like if you were hiking this
Oh,
trail,
yeah.
if you're hiking, yeah, absolutely. So minus 2.25 comma minus 84.39, that is an absolute min. Now what's going on up here at 1 comma 5? Like when you get there at the trail, are you at the top or do you have more to go?
That's the top.
The top. So we'll call that the absolute max. And then what's going on down here? Well, it's a min, but is it the lowest point? No, the lowest point was down here. So we got minus 34.79. That's a relative min because it's a min, but it's only relative to the um,
Okay. Let me type it in.
I always tell students this, but I would ask my instructor, and they'll probably say no. But you can always ask. I say, "Can I use this graphing tool? It's really cool. Like I understand it. It's in color, and it's not on a little small screen. Like
Yeah.
as if we don't have cell phones and things that we've been
Yeah.
using for 10 years that make this way better. But Some instructors, take the bus to school when they should drive a car, and there's just the way they are. I don't know.
Yeah.
Um,
Okay, I got that right, but there's another. Can I send one more real quick that
yeah,
we can
yeah,
do?
yep,
Okay.
absolutely.
Okay.
All right, I see you've sent some more screenshots. Maybe we got one more question here. Okay. So this one is something we can do by hand because it's a closed interval because of those brackets that you see there. That's when you test the endpoints. I got kind of ahead of myself in the last one. So you immediately you say, okay, I'm going to try. Well, what happens at e to the -1? What happens there? And then you do the same thing at 1, which is e to the 1 -1, and you get numbers here, like whatever you get. I mean, that's totally okay. Actually, they want exact, so this means this is e to the -1, which is 1 over e plus 1, and this is e minus 1. You'll probably want to go to your calculator just to get an approximation for these. This one is going to be around like 1.33. This one's going to be around 2.78 ish.
Okay.
So like we have an idea that way we know like whether something's bigger or smaller.
Okay.
So now the next thing is to find the derivative. What is g prime of t
Oh, it's just e to itself in the
minus what's the root of t?
1.
All right. So now where does this equal 0? And this could be a little.
Oh gosh, I don't know.
So move this over to the other side. So it's e to the t equals 1. And then to undo e, it's natural log. Natural log of e to the t equals natural log of 1. T equals 0. Natural log of 1 is 0. And your calculator can help with that, if you're not sure. This
Okay.
number, by the way, it needs to be between -1 and 1. Whatever your window is, like whatever they tell you. Like if you got 10, well, that's not in the window. So you would ignore it.
Okay.
So now you go back. I'm going to scroll up because we actually want to look at all three of these numbers together. You can find g of 0. So g of 0 is e to the 0 minus 0, which is 1.
Okay.
So out of these on the right, which is the smallest or which is the largest?
The smallest or largest?
Either one
The smallest is a 1.
is the one. Okay, so we've got this is -1 comma, and then it wants this 1 over e plus 1 in here. This point here, 0 comma 1 is right in the middle, and then 1 comma um, e minus 1.
Okay.
And then I got ahead of myself. So 1 is the smallest. So this is the absolute min. And then which is the largest? It's this one. So that's the absolute max. And then this other one's a little bit hard for me to tell you. If we kind of make a real quick graph of what these look like. So at -1, it looks like it's there. At 0, it's there. And then it looks like at 1, it goes. So it looks something like this,
Okay.
roughly. And that's how we got, oh, that's the absolute min, that's the absolute max. Well, this point over here, which is this top point, how does it compare to the others? Like, is it a little higher? Is it a little lower? What do
This
you
is the
say?
relative max.
It's a relative max. Absolutely. Good.
Okay. Okay. If it's saying find the, what should I round to?
There's nothing to round on this one. Are you asking about number 8?
Yeah.
So you have to enter it exactly the way I've shown here.
Oh,
Yeah.
okay. So not
The,
okay.
these numbers are just because you don't, I mean, you're not a, I mean, like me, I mean, I don't know what 1 over E is. I have to go calculate it and get something that, makes sense here.
Okay. Thank you.
You're welcome.
Okay. I honestly think that's it.
Great. So thanks again for scheduling. I know you rescheduled. Just to let you know, if you do it within 24 hours, I think that's when you get hit with the fee. But just let me know when you want to schedule again, and be happy to help.
Yeah. Okay. Thank you.
You're welcome. Have a great night. Bye now.
Bye.